T-minus 3 minutes, 20 seconds and counting. Everything remains go.
T-minus 3 minutes.
Prop 1, vehicle fuel tank press, open. Open. Fuel and milk. S&A's armed. First stage armed. Second stage armed. Armed. FSC, BAT 1, heater control, exit. Exit. BAT 2, heater control, exit. Exit.
T-minus 2 minutes, 30 seconds and counting. NASA launch manager Omar Baez informed ULA launch director Tom Heater that NASA is go for launch. At liftoff, the Delta II RS-27A engine and 6 of the 9 solid rocket motors will ignite, generating more than 1 million pounds of thrust. The remaining 3 solid motors will ignite about 64 seconds after launch when the first 6 solids burn out.
Minus 2 minutes.
T-minus 2 minutes and counting.
Prop 1, pressurized vehicle launch tank. Pressurizing. FAC, establish pulse suppression, water on.
Roger.
1 minute, 45 seconds away from launch.
SSC, hydraulic external power on. External. HYE, check hydraulic pressure, go. Go.
1 minute 20.
Topping to 100%.
One minute 10.
SSC, hydraulics internal. Internal.
T-minus 1 minute.
Rock, report range status. This is Rock, range is green. LC, T-minus 60-second limits on.
And the range operations controller reports that the range is green.
T-minus 45 seconds and counting.
LC, launch enable to flight. Flight. ATC-3, main power disable on. On.
Minus 35.
Hydraulics are go.
T-minus 30 seconds.
Status check. Go Delta. Go JPSS.
Minus 20 seconds.
Launch conductor Scott Bunny reports a green board. Everyone is go.
T-minus 6, 5, 4, 3, 2, engine start, 1. And liftoff of Delta II and NOAA's Joint Polar Satellite System 1, making the U.S. a more weather-ready nation.
The Delta II is proceeding on a flight azimuth of 196 degrees, just to the west of 180 degrees south.
Looking good. Also seeing a good symmetric burn across all 6 ground-lit solids.
We're listening to the voice of Patrick Moore, ULA flight commentator. 33 seconds into flight, the Delta II rocket will reach Mach 1, breaking the speed of sound.
30 seconds. Chamber pressure on main engine and veneer engines continue to look good. Now passing Mach 1, Delta II is now supersonic.
At 49 seconds, Delta II
continuing
encounters
to see a very symmetric burn across all 6 ground-lit
maximum
solids.
aerodynamic pressure, or max Q. This is the point where the mechanical stress in the rocket
Now
reaches
passing
its
48
peak.
seconds, max Q, maximum dynamic pressure.
The 6 ground-lit solid rocket motors will burn out about 64 seconds into flight.
Tail off.
The 3 air-lit motors will ignite a second and a half later.
And we have burnout and ignition of the 3 air-lit solids.
Approaching the jettison of the Delta II graphite epoxy solid rocket motors in 3 sequences of 3. The first 3 will fall away 1 minute 26 seconds into flight, followed a second later by the next 3.
Now 1 minute 25 seconds into flight. And we have good jettison of all 6 ground-lit solids.
The final 3 air-lit motors will continue to burn until they are jettisoned 2 minutes 11 seconds into flight.
Flight. Chamber pressure on the main engine, both veneer engines continuing to remain very stable. Gas generator, fuel, and LOX injector pressure is also looking very good.
And we're standing by for the jettison of the final 3 solid rocket motors.
Chamber pressure is on the air-lit solids tailing off in preparation for burnout. And we have burnout of the air-lit solids and good jettison of all 3 air-lit solids. And the booster LOX tank press valve has been opened. LOX tank ullage pressure response looks good. And now 2 minutes 50 seconds into flight, now passing Mach 10.
The next major milestone is main engine cutoff, or MECO. The first stage RS-27A main engine will cut off.
And 3 minutes into flight. Engine operating parameters on main engine and both veneer engines continue to look good.
MECO is scheduled for 4 minutes 20 seconds after liftoff. That will be followed.
And it's 20 seconds into flight. Just 1 minute remaining now until main engine cutoff. And vehicle body rates have smoothed out nicely now as the vehicle continues to climb through the upper atmosphere.
Nine seconds after MECO, we'll have separation of the first and second stages of the Delta.
Into flight. Main engine chamber pressure looks good. Both veneer engine chamber pressures continue to look good. Gas generator, fuel, and LOX injector pressures remain very stable. Vehicle body rates also looking very good. Now at 4 minutes into flight, about 20 seconds remaining until main engine cutoff. Following main engine cutoff, the veneer engines will continue to burn for a few additional seconds to maintain attitude control, leading up to stage separation. Standing by for main engine cutoff momentarily. And we have MECO, main engine cutoff, and VECO, veneer engine cutoff. And we have good indication of stage separation, standing by for stage 2 ignition.
The first and second stage, the Delta II, have separated.
Stage chamber pressure looks good.
And ignition of the second stage.
And we have a good indication of fairing jettison. And vehicle body rates have smoothed out nicely from the staging events. Now 4 minutes 50 seconds into flight. The first burn of the second stage will last just under 6 minutes.
The payload fairing that protected NOAA's JPSS-1 during its dynamic flight through the atmosphere has been jettisoned, exposing JPSS-1 to space for the first time.
This first burn of 4 for the second stage on Delta II will position NOAA's JPSS-1 in its correct orbit. The third burn will position a series of CubeSats in their proper orbit, and the fourth burn will be a disposal burn of the Delta II second stage. All of these burns happening over the next hour and 45 minutes.
Now passing 5 minutes 30 seconds into flight. About 5 minutes remaining in the first burn of the second stage. Vehicle body rates continue to remain very smooth. Chamber pressure on the second stage engine looks good. Hydraulic system pressure on the second stage also looking good. Fuel and oxidizer feed line pressures remain very stable in nominal values.
Six minutes
now
into
passing
flight.
6 minutes into flight.
Listening to Patrick Moore, ULA flight commentator.
And now passing 6 minutes 30 seconds into flight. 4 minutes remaining until engine cutoff. Chamber stable. Fuel and line pressures also remain very stable within family. Hydraulic system pressure also remaining stable. And seeing a nice decay profile on the helium bottle pressure, as expected.
Recapping where we are. The Delta II rocket launched at 1:47:36 a.m. Pacific Time, carrying the Joint Polar Satellite System 1 inside a payload fairing atop of the rocket. The Delta II first and second stage engine with 9 solid rocket motors.
7 minutes, 30 seconds into flight.
And the Delta second stage have performed well.
It's remaining very smooth, close to zero on roll pitch and yaw body rates. Second stage engine continues to perform well. Chamber pressures and fuel and oxidizer feed line pressures continue to look good. Now 8 minutes into flight.
Coming up on 2 minutes until second stage engine cutoff number 1 at 10 minutes 30 seconds after launch.
And just under 2 minutes remaining now in the first burn of the second stage.
Nine minutes into flight. NOAA's JPSS-1 satellite atop the Delta II second stage.
Now just over 1 minute remaining in the first burn. Second stage engine continues to perform well. Chamber pressure well within expected values. Fuel and oxidizer feed line pressures also remain very stable. Hydraulic system pressure within the expected range. And body rates continue to remain very smooth, close to null for all body rates.
About 30 seconds
30
away
seconds
from
remaining
second stage engine cutoff.
And standing by for SECO 1 in approximately 8 seconds. And we have engine cutoff. Vehicle body rate response is damping out nicely from the cutoff event.
And as you hear from Patrick Moore from United Launch Alliance, SECO 1 is confirmed, beginning a coast phase of just over 40 minutes. The engine will reignite at about 2:38 a.m. Pacific time, 50 minutes, 47 seconds into flight.
This first coast of the second stage should last approximately 40 minutes.
We are awaiting some key milestones in the mission. NOAA's JPSS-1 is scheduled to be deployed at 2:44 a.m. The JPSS-1 solar array is expected to be deployed by 2:50 a.m. And 5 CubeSats are scheduled to be ejected from the Delta II beginning at 3:08 a.m.
And in just a moment, we will be pleased to be joined by United Launch Alliance Program Manager Scott Messer to talk about the success of today's launch.
Now passing 12 minutes into flight. Just over 1 minute into the coast period. Main vehicle systems all appear to be operating nominally. Vehicle battery voltages and currents all within expected values. Helium and nitrogen bottle pressures all at expected values as well. And vehicle body rates all remain very stable.
And we are now pleased to be joined by United Launch Alliance Program Manager Scott Messer. Scott, can you tell us a little bit how the countdown went today?
Yeah, the count was very smooth today. Weren't bothered by several issues that we've been working over the last several attempts, so it was very nice, and the performance is nominal.
Yeah, that was it was a beautiful launch. It was good to see, and we were happy that the upper level winds cooperated. The Delta II has been a workhorse. We've heard that a number of times. Can you elaborate on that for us a little bit?
Yeah, sure, Mike. So the Delta II this is the 154th launch of the Delta II vehicle over approximately a 28-and-a-half-year period. Its first launch in February of 1989 for the GPS mission, and since that time it's launched over 50 satellites for NASA, including Earth observers and weather satellites similar to JPSS. This evening it's launched scientific and interplanetary missions similar to the Spirit and Opportunity rovers, as well as a series of communication satellites. So it's really spanned the entire spacecraft market, and with 154 launches over 28 years, I think everybody would agree it's earned its position as a workhorse in the industry.
Yeah, that is quite the track record.
And when is the last Delta II launch?
So this is the penultimate launch of the Delta II, so we're expecting to launch the last Delta II in September-ish of next year with the ISAT mission, so we're excited for that.
This is a coordinated launch effort by a whole lot of folks, including NOAA, NASA, the Western Range, and United Launch Alliance. NASA LSP selected United Launch Alliance for this launch, and you guys have had quite a string of successes.
Yes, we have. In fact, this will be 122 missions with 100% success as United Launch Alliance. So we're very excited about that, and appreciate the opportunity to launch this critical spacecraft for our customers.
And what is next for United Launch Alliance?
Oh yeah, so it's an exciting year coming up. So still this year we've got the L-47 launch, which launches in mid-December. And then next year we've got a full launch manifest, including 6 satellites for NASA. We start in the March time frame with the GOES-S satellite, and then Parker Solar Probe in so these are on the East Coast. Parker Solar Probe in July, followed by OFT and CFT, and then back here out on the Western Range, we'll launch the InSight mission in May time frame. That'll be an exciting launch. It's the first Mars mission to be launched from here out on the West Coast, so that'll be exciting. And then, as mentioned, we'll end with our last Delta II launch of the ISAT mission in September. So it's a very exciting and full year for both ULA and NASA.
Yeah, it sounds like it. You have quite the full plate coming up, and it's going to be an exciting year coming up as well. And we are very excited about how things have gone so far this evening. I really want to thank you for joining us, Scott.
Well, thank you. Appreciate that.
So as things continue to go well, and we are in the middle of the long coast phase, taking NOAA's JPSS-1 spacecraft to its designated place in space. For now, Tori, we will hand it back to you.
Thanks, guys. So what a beautiful launch we just we just witnessed. That was truly incredible. We'll check back in at the Launch Control Center later on. For now, let's take a closer look at NOAA's JPSS-1 spacecraft. NASA Edge's Blair Allen spoke with Mitch Goldberg, project scientist for JPSS-1.
Mitch, what is the Joint Polar Satellite System?
Well, the Joint Polar Satellite System, which we call JPSS, is NOAA's new generation of operational weather satellites.
Now, last year we covered the launch of GOES-R. How is JPSS different from GOES?
Well, let me start with GOES-R. GOES-R is a geostationary satellite, so it's at an altitude about 22,000 miles above the equator, and its orbit is moving at the same speed as the rotation of the Earth, so it's always overhead monitoring weather in real time. JPSS is a polar orbiting satellite. It orbits from the North Pole to the South Pole, or the South Pole to the North Pole, at a lower orbit, about 515 miles. And as it's orbiting in that same orbit, the Earth is actually rotating underneath it, and we get global observations. So the global observations from JPSS are critical for weather forecasting. So our primary mission for JPSS is to forecast weather out to 7 days. GOES-R primary mission is to watch weather as it unfolds.
So how are you going to use that scientific data that you get from this polar orbit to do that, to predict weather?
Right now, polar satellite data have been used by numerical weather prediction for years, for the last 20 years. So the information is not totally new. We always had atmospheric sounders. JPSS provides us now with this more advanced capabilities, more advanced observations. And then also the program extends out to 2038, so we have this continuity of critical observations. Now, 85% of all data that goes into weather forecast models come from polar orbiting satellites like JPSS. So it's really a critical data set. So basically the data is processed in this building and it's delivered to the National Centers for Environmental Prediction, and they ingest it right into their weather models, and they basically give updated forecasts. So for example, the Hurricane Irma, if you recall, Tuesday morning, I think it was September 5th, they showed that the forecast would take it Sunday morning right off of Key West. And guess what? That weather forecast was spot on. That 5-day notification, that allowed FEMA to get ready, and state governments to get ready for this major disaster.
Clearly, JPSS does more than just work on weather prediction and forecasting. What are those things that you do beyond that?
So recently we responded to Hurricane Harvey and Irma, and now Maria, with generating flood maps. We used the VIRS imager to generate maps of where flooding took place, and that was very important for FEMA for their recovery efforts.
Is there any example of previous weather prediction that didn't have these polar orbiting satellites, and somehow the data, if we'd had it, maybe we could have benefited from it?
Hurricane Sandy is a really good example. If you recall, that 5-day forecast was pretty accurate. It showed that the hurricane was going to move up the coast and make a left hook right into New Jersey, right in that area. And the European Center for Medium Range Weather Forecasting, they did a study after the fact, and they pulled out all the polar orbiting satellite, which means that all those sounder information was unavailable. They reran the forecast, and guess what? The 5-day forecast showed Hurricane Sandy being way out to sea, way far, like hundreds of miles off the coast, probably 600 miles off the coast. So that was a scenario that was forecast. People would not have been able to prepare for that event, you know. And in reality, eventually the forecast would be right, but it would probably be more like a 2-day forecast. And you cannot prepare and evacuate people with only 2 days' notice. It takes a long, as a good example was the Irma case. It took a lot of planning to be able to evacuate all these people.
And I guess that's why JPSS is planning is a system and planning satellites far into the future.
Absolutely. So when you think of satellites, each satellite has a design life. It can only last so many years. Some satellites are luckier than others, right? Some will last for 20 years, even though it's designed for 5 years. But this information is so critical to the nation that you can't take those chances. So we have a series of satellites from JPS-1 through JPS-4 that will maintain continuity of these critical observations well into the late 2030s.
We are now launch plus 21 minutes and counting, and I'm joined now by the director of the Joint Polar Satellite System program, NOAA's Greg Mant. Greg, congratulations on the launch, and thanks for joining me.
Thank you. It's an exciting time for all of us in the JPSS program.
It certainly is. So tell us, how big of a deal is launching JPSS-1?
Oh, this is a huge deal. You know, the JPSS-1 is part of a national polar orbiting weather satellite program. And we really need this because 85% of all the data from our weather forecast models come from these series of satellites. So the last one we launched was back in 2009. So we've been a little anxious about keeping this gap to a minimum. So having the satellite up now, and we'll get testing it. So looking forward to getting good data from the satellite.
Great. So now that we've launched, what's next for the satellite?
Well, the first hour is really the booster show, so the Delta II gets to show its stuff, getting us up to orbit. Then the exciting time is we've got to turn it on and connect to our communications to the Satellite Operations Center in Suitland, Maryland. So we'll turn on the communications and make sure that's all working. And then the big deal, we turn the solar array, deploy the solar array, and we start to see the systems power up and start talking and working the satellite.
Okay, so once JPSS is operational, what's next for the program?
Well, the program is really all about continuity. So right away, we'll be working on J2 and finishing that up and doing a lot of testing there. But I think as you saw Mitch just talk about, this is an international program. So we got a lot of partnerships. We take data down from the European satellites, DoD satellites, Japanese satellites, and we're all working with them on their next generation. So we've got a lot of activities here with the Europeans, where their next generation requires a lot of modifications to ground sites. So we're working some ground site changes up in Svalbard and down at the South Pole. A lot of exciting stuff doing there. So we have to work with the National Science Foundation and really beefing up the ground system to handle next generation satellites. But it's an exciting time, and it will be for some time.
Well, congratulations once again, and thanks for joining us.
Thank you. Go JPSS.
Yes. The United Launch Alliance Delta II rocket carrying NOAA's JPSS-1 lifted off from Space Launch Complex 2 at Vandenberg Air Force Base in California about 24 minutes ago. We'll check back in with Mike and Josh at the Control Center in just a few minutes for an update on the count. First, let's turn our focus to the scientific instruments on board this mission. Now, let's take another look at today's spectacular launch. Sit back down. B-19. addition to NOAA's suite of instruments aboard JPSS-1, NASA is also contributing a scientific instrument called Ceres FM6. Blair from NASA Edge spoke with Ceres FM6 program manager Kevin Dougherty on their Tower Rollback show.
Joining us now is Kevin Dougherty for Ceres FM6. Kevin, great to have you on the show.
It's great to be here.
And I want to start right away. What is Ceres exactly? Because it's different from JPSS-1.
It is. So Ceres stands for Clouds and the Earth's Radiant Energy System. We're actually trying to study the energy balance in the atmosphere or in the entire Earth. So the Earth receives a lot of energy from the sun, and as it absorbs the energy, it then reflects some of it immediately, and it emits some other radiation, some longer wave radiation at nighttime.
Now, was there any difficulty for your instrument in terms of riding on JPSS-1? I mean, you're not in competition with them. They gave you a big window for you to get your data?
No, we're not in competition at all. In fact, we actually, as part of our data processing, use a lot of the information from some of the other instruments. So it's great to be on the same ride with them. And actually, in fact, on NPP, the predecessor, we were with some of the same instruments, and it's proven to be a very valuable cooperation.
Oh, that's serendipitous to have that kind of complementary relationship. Now, I'm wondering, this is FM6, which is Flight Model 6.
Yes.
What about the previous 5? Are they still in operation?
So there have actually been 6 previous ones, despite our number being number 6.
Okay.
The first one was a proto-flight model, and that was on trim, and that is no longer in operation. But Series FM 1 through 5 are still all up and in flight. So we have 2 of them on the Terra spacecraft, 2 on Aqua, and 1 on NPP.
Okay, so that's great. Now, I understand that JPSS-1 is in a polar synchronous orbit. Wait, no, that's not right. Just polar
Sun-synchronous.
Sun-synchronous, but polar orbit. Was that a mission parameter in all the other Ceres instruments flying in a similar orbit?
It is. So all of the Ceres instruments are in what we call sun-synchronous orbit, which means that as the Earth rotates, or as the Earth goes around the Sun, the orbit rotates as well. So the advantage that we get from that is that we can see both daytime and nighttime, but when we ascend over the equator, when we're passing over the equator, the spot on the Earth below us is always at the same time of day. So that gives us an advantage to see the Earth at the same time, see a little closer up than we would get from a geosynchronous or further away satellite.
I'm noticing this about scientists and collecting data at the right time and the similar time and building this continuous data record that they can look at. Is that a big part of what you're trying to do with Ceres?
It is a big part, and also on the NPP spacecraft, with JPSS-1, we're actually going to be on the complete opposite side of the Earth from NPP, so that we'll get a better coverage of the Earth as we move along.
Okay, so is this the last of the Ceres models, or are there more in the future?
So this is the last series in the series, but there is a follow-on coming up. There is a follow-on coming up called the Radiation Budget Instrument, where they are redesigning the technology to try to get an even more accurate measurement.
To learn, NOAA will collect and process NASA Edge's interview with NOAA's Office Satellite and Products Griffin.
So and at that time, telling me that some changes were going to be made to the NOAA satellite operations facility.
Yes.
Have you made them yet?
We have, in fact. You're sitting in the middle of our new operations center. So in the last year, we've totally demolished and reconstructed our entire operations floor, and where we operate all of our satellites in order to be able to accommodate operations of GOES 16 now, which was GOES-R, as well as the JPSS-1 satellite that launches in November.
Now, are you talking a few cosmetic changes, a table here, a monitor there, or is this a total demo rebuild?
Oh, it's complete reconstruction. So we moved all the operating teams off the floor to different places in the building temporarily. We completely gutted everything in the floor, all the consoles, all the monitors, replaced everything. At the same time, we rebuilt the floor up to hold more equipment and heavier weight. We actually added redundancy to our power systems as well as our comm systems, so that if we had a problem with a unit, we wouldn't lose operations on the floor due to a single failure.
Now we're talking about JPSS-1 for this show. How are you supporting JPSS-1 here?
Okay, so to get ready for JPS-1, basically our team had to take that ground system, learn how to operate it, learn how to use it to operate our current satellite, SUMI-MPP, verify that SUMI-MPP can be operated successfully on that ground system and bring it into operations. We just completed that last month. So we now have Sumi and PP flying on the new ground system, the version that will be used to launch and operate J1. And of course, we then have to get ready for J1. Learn all the things about the J1 satellite that we need to do to be able to operate it, bring it into operations at launch plus 90 days.
NASA and NOAA are partnering on this mission. Tell us how that partnership works.
Well, it's a good partnership in that, of course, NOAA is responsible for the overall JPSS program, but we rely on NASA to build a satellite for us, in this case also to build the ground system and to launch the satellite. So once we get ready for launch, the satellite launches on the NASA-obtained rocket, and once it separates, then we actually bring it and operate that satellite out of our launch control facility behind the wall here. And that's a NASA team. It's a NASA team of NASA employees and NASA contractors, supplemented, and of course NOAA's part of that as well, so we're getting used to operate the satellite and see how it works. But they operate the satellite for the first 90 days. So over those 90 days, they'll check out all the satellite systems, they'll make sure the instruments are working as required. Anything that's different than they expect, of course, they'll work on how to accommodate those differences, how to respond, any process changes required to actually operate the satellite because of things they see in orbit. And then at launch plus 90 days, they'll hand all of that over to my team, and then we'll start operating the satellite from this facility, this floor, mid-launch plus 90 days. So we actually embed some of our people with their launch team, the launch crew as you called it, so that they get training and they get exposure to the satellite, and they know how to operate the satellite, know it's, idiosyncrasy. Every satellite has idiosyncratic behavior occasionally, so they'll learn how to best operate the satellite in an effective way, and then we'll move it into operations at launch plus 90 days, and it becomes mine, or ours.
Hours, yeah. So in the room here, at any one time, how many satellites are controlled here?
Right now, we're controlling 17 satellites.
In this room right here?
In this room right here. We control 9 NOAA satellites, and we control 7 non-NOAA satellites as well. So, like, we fly satellites for the Air Force, their Defense Meteorological Satellite Program, or DMSP satellites. We fly them for the Air Force here. We fly our own satellites, and of course, we'll be adding J1 in November, 90 days after launch.
Once the data is collected, the question then becomes, how will it be used? NASA Edge interviewed National Weather Service Director Joe Pica to learn how scientists will use the data to learn more about our planet and improve weather forecasting.
And welcome back to NASA Edge. We're joined now by Joe Pica from NOAA's National Weather Service. How you doing, Joe?
Good, Chris. How are you?
Mitch did a great job giving an overview of the JPSS mission. Let's turn our attention now to the user side. How will you, as a weather forecaster and a meteorologist, how will you use that JPSS, the data, in your daily forecast?
So the JPSS-1 data is really the latest in a line of polar satellites, and they're the backbone of all the information that goes into our global weather prediction models. Right. So that's what is used to provide that 3 to 7 day forecast that we get to the public, to emergency managers, so they can prepare for a landfalling storm, forest fires, tornado outbreaks, whatever it is. The polar satellites are the backbone of that data.
Now, when we look at JPSS, that's the next generation of polar orbiting satellites. GOES-R, that we talked about a year ago, we had you on our show a year ago, is sort of the next generation of geostationary satellites. So how we have JPSS and GOES work together and get the data that you need?
So both GOES and JPSS are complementary type satellites. So the geostationary is at 22,000 miles above the Earth, and it stays in a constant place to basically look over and maintain watch on the weather, what's coming right now. Where the polar satellites gather the data that feeds into the global models to predict what's going to happen several days in advance.
Okay.
So an example would be Hurricane Irma.
Okay.
For Hurricane Irma, the geostationary is able to look and see where is the hurricane now, what's going on. But then the polar data was used. Well, where does it go? Does it strengthen? Does it weaken? Where's it going to be, so we can provide that warning to folks, right, and they can prepare.
So with GOES, I think it's GOES 16 now is what it's called?
That's correct.
So when you were getting that data from GOES 16, if I recall, you were getting data much faster than the older generation GOES satellites.
That's correct. 5 times faster, with the ability to download it every minute if needed.
Now, how is that going to be different than the JPSS data that forecasters will receive?
So whereas the geostationary data is downloading every 5 minutes. The JPSS is orbiting the planet to get global observations, and that's what we need for weather prediction models. So it basically traverses the Earth or orbits 14 times a day, passing over the same spot twice a day, and then we download that data twice in orbit.
Now we have, this is the second in the series, so really it's the MPP, or was it Xiaomi?
So Sumi and NP was a demonstration project that we brought into operations in 2014 so that we would avoid a gap. And JPSS will be the first of the operational series, and it will be known as NOAA 20.
NOAA 20.
When it gets to operations.
So MPP was sort of bridged the gap between the older polar orbiting satellites with the next generation.
That's correct.
So this is kind of interesting. So all this data that's being collected, I mean, where is that going to for NOAA?
So a couple of places. We feed that into our models.
Okay.
And so those high performance computers we have run the models so we can issue those forecasts. Right. But then it's also stored in our National Centers for Environmental Information so it can be looked at later.
So not just meteorologists and weather forecasts around the country or even around the globe gets access to that data, but also scientists who want to use it for maybe long-term predictions?
That's correct. So folks who want to do long-term climate studies can take a look at it later on. I will mention that it also goes to our international partners because weather is a global phenomenon.
Right.
And we actually get data from our European partners from their polar satellites as well. So it's a share so we can all provide that mission to protect lives and property.
Now you went back with Hurricane Irma, and as a public user who watches the Weather Channel and other weather organizations. Now you always see these models on TV. You see the European model, the American model. They have all these different initials for these models. How does JPSS and even GOES, which models do they fit in with that data?
So all those models actually use this data.
Oh, okay.
They all rely upon this data, and we use that with some forecast expertise, like at the Hurricane Center, to issue an official forecast. And for Irma, you'll note that our forecasts were really good, and that basically 6 days in advance, the governor of Florida was able to issue a state of emergency to begin preparations before that storm made landfall.
I mean, that's got to make you feel pretty proud that we have a satellite that's up there that's capable of doing something like that.
Absolutely. Our job is to protect lives and property, and when our forecasts, our predictions have enough confidence that decision makers, emergency managers can make decisions several days in advance to protect their local communities, that really is what our mission is.
And the cool thing about it is that this is just the first JPSS one. You're going to have another, 5 satellites going up over the next 5-10 years?
4 satellites. So this is the first of 4.
Okay.
And they basically have 7-year lives.
Right.
And at the 5-year mark, the next satellite would be launched.
Gotcha.
So that we ensure continuity.
And so each satellite will be basically the same satellite with the same instruments on board?
That's correct.
Okay. And that's also the same with GOES. I mean, you're having a series of the next generation GOES satellite that's going to be replacing the older system.
Absolutely. We have GOES-S scheduled to launch in March next year.
All right, so that's the next one. So where will GOES-S go? Where will GOES-S be in the hemisphere in terms of where it's going to be looking at the Earth?
So GOES-16 is actually going to move to GOES East in December. So it'll take over its operational role. Okay. We'll launch GOES-S in March. It'll go through its checkout and evaluation, and it'll become GOES West. We actually have 2 in orbit that are operational east-west, and then 1 in a backup location in the center.
It's 45 seconds into flight. Now 10 minutes remaining in the first coast period until the restart of the second stage engine. Vehicle systems all continue to look good. Helium and nitrogen bottle pressures remain stable. Seeing consistent vehicle body rates in roll, pitch, and yaw. Very little change in the last several minutes. And vehicle battery voltages and currents also remaining stable.
We're now moments away from spacecraft separation. Let's go back to Delta Launch Control for an update. Mike and Josh?
Thank you, Tori. We've been